Hey math kids, today we're going to talk about parabolas, and I'll start by drawing a few things. This is going to be a different way than we've talked about them in the past. Alright, I keep drawing that. There we go. Okay, so some things that we've talked about in the past. This point right here is called the vertex. I guess that's it. Now this point right here that's inside of the parabola is called the focus. And then this line down here is called the directrix.
Tasia, you're getting checked out. Tasia, can you come to the front office?
And then this will come into play, but the distance from here to here and the distance from here to here is the same, and we're just going to call both of those P. Now something that's kind of significant is, let's see, what color can I use? I'll use gray. If we draw a line to the parabola and then we go to the shortest point that touches the directrix, these distances will always be the same. So for example, if this is 2, then this one is also 2. Now if we do it here, and then here, and let's say that was 1, this would also be 1. And just like the P, so from here to here is P, here to here is P, so that also works. Okay? Now we have two equations. So we have a vertical parabola, and that's going to be 4p y minus k x minus h squared. And we also have a horizontal parabola, and I will draw pictures of these in just a second. And it's the same equation, but you just switch the x minus h and the y minus k. Okay? And so this is going to be the parabola. We have the focus right here. We have the vertex, which is h comma k. And then we still have the directrix right there. Okay? Once again, we have the distance P from here to here. So this is the focus. There's P, there's P. I know on the diagram those don't look the same, but if my diagram was better, it would represent that. Now this one, I'm going to draw the directrix right there. This is the vertex. We have a sideways parabola. So this is still h comma k. Then we have the focus right here. And once again, the distance P is going to be from here to here and here to here. Okay? So let's try one of these. So if we have y minus 3 quantity squared equals 8x minus 5, the first thing we want to do is label this as horizontal or vertical. So since the y is being squared, it must be horizontal. Okay, so we know it's going to look like this or like this, and that all depends on our p-value. So if our p-value is positive, then it looks like this. If the p-value is negative, it's going to be on this side, and then have the directrix over there. We'll have the focus right there. Okay. With the vertical one, this is a positive one that's shown, and a negative p-value would flip it upside down right there. Okay? Okay, so for this one that I wrote in blue, right here, we need to find the vertex, directrix, and the focus. So the vertex is just going to be h comma k. So if we look right here, h is grouped with our x value, and it's the opposite sign, so h is a 5. K is grouped with our y, and it's also the opposite sign. So our vertex is 5, 3. Now from our formula, 4p is the thing that's out in front of x, and so this 8 is equal to 4p. Then if we just divide both sides by 4, we see that p is equal to 2. So if p is equal to 2, so if we have a horizontal parabola that's positive, it's going to look like that. We have our focus, we have our directrix, we know our vertex right here is at 5, 3. We know the p-value is 2. So what's going to happen is our focus is going to be 2 to the right from our vertex. So that's going to affect our x value. And so the focus is going to be this same value, but just adding 2 to the right. So the point right here is 7, 3. Okay. Now the directrix, same reasoning, but we go this direction by 2, because that's our p-value. And so the x value is 5. Now the x value is going to be 3. And since it's a vertical line, we're going to say x equals 3 for our directrix. So we found the focus, directrix, and the vertex. And so we are done with that one. Okay. Now we want to find the equation. Alright, that's weird. Equation of a parabola that has a vertex of 0, -5, and a directrix of 1/4, and we're given that it's a vertical parabola. So what I'm going to do, I'm going to just rewrite the vertical formula that was written above, and we're going to use the info that we have to figure this out. So when we're doing this, we have let's see, we have 0, -5, so we're going to plug that in. So I'm going to just keep 4p for a second. Now we're going to get y minus a -5, then x minus 0. And that just becomes 4p y plus 5 equals x minus 0. I'm going to keep the x minus 0 in there, even though we don't absolutely need that. Okay, now we have a vertical parabola. We have a focus that's somewhere. We have some p-value. We have that same p-value going down here. And then we have a directrix that is at -5. Now, or not -5, 1/4. Okay. Now, when we're looking at that, this doesn't make sense because this is at -5 and then we go down to be 1/4. So that tells us that we actually have the upside down parabola and we have this situation. So from here to here is going to be -5 and 1/4. So we want to know the difference between that. So we're going to have 1/4 minus 5, and that's going to tell us our p-value. So the distance from here to here. So I'll change the 5 to be 20/4. So that's going to be -19/4 is our p-value. And when we plug that in for this p, we get 4 times negative 19 over 4, y plus 5, that's equal to x minus 0 squared. And these 4's are going to cancel. And so we get negative 19 y plus 5 equals x minus 0. And then if we wanted to simplify, we could write it like that because of the minus 0. So either of those answers are acceptable, just whatever one you think looks better. Okay? Now we're going to do, we're given that we got a focus at 0, 1 and a vertex at 0, 0. And let's look at that for a second. So we draw it, and 0, 0 is the vertex. I'm just going to take a guess that we got this. And the focus is at 0, 1. Okay, so I guessed right. So what that means is that the directrix, because it has to be the same distance away, is going to be at negative 1. And we do have a vertical parabola, and our p-value is 1. Okay? And so if I write out my vertical equation, and plug in the values, so plug in a 1 for p, these are both 0. 4 times 1 is 4. Y minus 0 equals x minus 0. So that would be one version. But then if we just simplify, it's just going to be 4y equals x squared. Okay, once again, either of those circled answers are fine. Okay, now this one, we're going to have to remember how to complete the square. So if you don't know how to complete the square, you should go back and watch that video before this part. Okay, now this is not written in the form that we've been studying today. So what we need to do is we need to get our x and our y's on different sides. And then we're going to keep the constant on the side with whatever's squared. So in this case, y. So what I'm going to do is write y squared plus 6y minus 15, and then I'm going to subtract this 12x onto the other side, so I get negative 12x. Now from here, I'm going to take just this piece and complete the square. So I don't need to divide, I don't need to move anything. Actually, yeah, let's move it. So add 15, y squared plus 6y equals negative 12x plus 15. We don't need to divide anything out right here, but we need to do the L step. So that's divide by 2, and then square. So that's a 9. So we're going to add 9 to both sides. And we get y squared plus 6y plus 9 equals 12x, and then if we add those together, we get 24. Sorry, it's negative 12x. Okay, then we do the magic step, y, and then the elbow, so plus 3 squared equals negative 12x plus 24. And from here, we just factor out. So this and this both have a negative 12. And we get x minus 2. And we get y plus 3. Alright, so we got the equation right there. So that's the equation of our parabola. Now we want to know the vertex, directrix, and the focus. So the vertex we can just pull out. So we look here, that gives us a 2. look here, that gives us a -3. That's our vertex. Okay. Now we need to find our p-value to find the other two. So remember, that's equal to 4p. So if we divide by 4, p is equal to -3. Now, I think graph, or at least like making a rough graph of this helps. So we go 1, 2, 1, 2, 3. And because the y is squared, we know that it's a sideways parabola. And because the p-value is negative, it's going to go something like this. Okay, so the focus is going to be 3 in the negative direction. So we're at 2, so it goes 1, 2, 3. So the focus is going to be at -1, -3. And then the directrix is just going to be 3 in this direction. So 1, 2, 3. And that's going to be at x equals 1, 2, 3, 4, 5. And that's the directrix. Okay. And then we just have one more problem to talk about. Does 0, 2, or is, I'm just going to say is, 0, 2 on the parabola with a vertex of 0, -5. So, and directrix of 1/4. So we just want to know, is this on the parabola that has these characteristics? So it doesn't tell us whether it's a vertical or horizontal parabola. So I'm just going to plot the vertex. So 1, 2, 3, 4, 5. And then 0, 2 is the dot, or the thing we want to know. So if this is a vertical parabola, this is going to be the closest thing we can get. But since these are vertically aligned, there's no way that it's going to fall on that parabola. If it's upside down, it's even worse because it's not even close. Now, if it's a horizontal parabola, you see this. Now, it's never going to be skinny enough, or wide enough. It's never going to be able to go like that, because it's still going to be off of the y-axis a little bit, and so it won't actually get to this point. And then even if we drew it this way, same reasoning, it would never be able to get to that point. So we can confidently say that this is not on this parabola. If you need additional help, please come to Math Lab. Until then, calculator.